Hello, this is John Ecken with Tandem Solution. In this video, I am going to demonstrate SQL Server's always-on technology. In our virtual environment, we have two SQL servers set up that will be joined together in an always-on access group by the name of AG1. Those network environment also has a domain controller, and we do have some client software so that we can simulate the always-on technology. We will be showing three main points in this demonstration. One is the ability to set up a contained database so that security can move with the database and not the server. Two is the ability to build an always-on access group and an always-on listener so that your clients can connect to that access group. And three would be to set up a read-only replica so that read-only applications would be able to read from the secondary databases and not the primary. So let's get started. We're going to begin by building a contained database. Microsoft introduced this technology in 2012. A contained database allows a security account to be assigned to a database, but not to the server instance. The advantage of this is that database can be moved from server to server without having to also move the logon accounts that go along with that database. So let's get started. On SQL 1, right now we currently have an AdventureWorks LT 2012 database. We are going to configure that to be a contained database, and then we are going to create a user for that contained database. To start this process, I first had to run a configuration on the server. So out of the box, SQL Server instances do not allow containment. So we needed to do our SP-configured contained database authentication, set that equal to 1, and then we needed to run a reconfigure so that it would allow those changes to take effect. Next, we're going to go into our AdventureWorks database. So I'm going to right-click on AdventureWorks, go down to Properties. I'm going to go to Options, and under Containment Type, I'm going to choose a partially contained database. I'm also going to ensure that the compatibility level is in SQL 2014 compatibility mode. Now our database is ready for partially contained accounts. To create a security account associated with the database, instead of normally going to security on the server instance, we are now going to go just into the security section on the database. We're going to right-click on Users, we're going to add a new user, and you'll see the first option that comes up here is SQL user with password. This will allow the password to be stored with the database rather than the server instance. You still can also choose SQL Server with logon to attach to a logon or a Windows user. When you create a Windows user, if you want to do a containment, you need to leave the logon name blank. So I've created my user account, I've assigned them to a schema, and I'm also going to assign them to the DBO administration role right now. What you will notice is that user account now exists under my database, but if I look under security of the instance, that user account is not found. If I go over to my application, I will show you that my connection string looks very similar. I'm trying to connect to SQL 1, the AdventureWorks catalog, user ID is Sam, and then the password that's being provided. Nothing else is unique about the connection for a contained database. The only thing that you have to have is the catalog has to be the same as the database containment account is. If we go ahead and run our client now, you'll see that we are able to connect and access our data. The advantage of our contained database is really the ability to move that database. So if I go into SQL 1 and I'm going to detach that database, I'm now going to use my operating system to copy the files from SQL 1 over to the SQL 2 data directory. So they're gone here. They're now over here. And then we're going to go into SQL 2, and we are going to attach that database. Again, security is still defined in the database user, not on the server instance itself. I can change my connection string to now point to SQL 2, and you'll see my application runs again. So the advantage of this is that one user account can be moved from database to database server without having to map logins, without having orphaned user accounts within your database. While this is nice, we still don't want that capability of having to go in and change our connection string. So that's where always-on technology really plays a big role here. So we're going to go ahead and set up an always-on availability group. I'm going to start by moving my database back to my original SQL Server 1. I want that to be my main primary database location. I'm going to recopy that data file back over to my original server. I want to ensure that it was removed from the secondary server. And then I'm going to go in and reattach that to my original location. For always on to work correctly, I'm also going to go ahead and make a new backup of this database. I need to back this database up into a shared location that all servers on my network will be able to access. Now we're ready to set up an always-on availability group. So if I go down to my always-on high availability, and I'm going to go ahead and run the new availability group wizard. It first asks me for the name of my group, so we're going to call that AG1. And then it asks me for which database do I want to be part of this group. The nice thing about Always On is you can actually have multiple databases a part of the same availability group. So if you've got an application that relies on 2 or 3 databases, all of those databases can be moved with the availability group. I don't have to move them one at a time. Next, I'm going to choose my replicas. So I'm going to allow automatic failover with synchronous commits, and I'm going to allow these replicas to be read-only. We'll talk about the read-only functionality in just a minute. I'm going to add in my second replica. In 2014, you can have up to 8 replica servers, and I'm going to set the exact same settings for my secondary replica. You'll also notice in 2014, you can add Windows Azure as a replica server. I'm going to choose the directory location of my backup. And it's going to check to make sure that everything is set up and ready to go. Okay, our validation has ran, and you see that everything is successful. You'll notice there is a warning on the listener, and that is okay. When you first set up Always On, if you do not have an initial listener, you're going to get a warning. We're going to go back in and set that up here in just a second. Here we get a nice little summary of what it's going to do. You can script this out if you don't want to run this right this second. You want to run this at a later time. And then we go ahead and we can hit finish, and it is going to actually create our always on availability group. Tells me everything was successful. I'll hit close. And now we'll notice a couple of things. We'll see that we have our availability group showing. We notice that on SQL 1, it is the primary group. If we go down to SQL 2, we will see that availability group available also, but we'll see that it's a secondary group. You notice AdventureWorks is now on SQL 2 also, showing a restoring state, but if I refresh that, it should already be synchronized and we're ready to go. So at this point in time, I need a listener. So even though I've got the availability group up and running, I still don't have a listener to allow client connections. So we're going to go back over to our availability group. We're going to see our availability group listeners, and I'm going to go ahead and click and say add listener. We're going to give the listener a name. This will be the machine name. So I'm going to go ahead and call it AG1 also, but this could be any name that you choose that clients would connect to. I'm going to choose the standard 1433 SQL port. And then I'm going to use a static IP address. And you'll notice on the subnet, it will allow me to add a listener group to any subnet that is managed. These are managed subnets also through the Windows clustering service. I'll hit OK now. And now I have a listener available for my clients to connect to. You'll see that if I try to ping AG1 now, it's going to answer just like a computer would answer on our network. I can now go into my client application and I can change my data source location to AG1. Go ahead and run my client, and you notice my connection works successfully. The nice thing about Always On, if an error occurs, or if I want to move the primary to the secondary, I can initiate a failover. So I'm going to go ahead and launch a manual failover. And now my SQL 1 is my secondary. My SQL 2 is my primary. If I go back to my application, go ahead and click to rerun my data, you'll see that I'm still accessing my data. You might have noticed a slight pause there. So as it was switching servers, the application did have to rebuild its connection from SQL 1 to SQL 2, but no errors and our application still runs just fine. So I'm going to go ahead and close that application out. I'm going to go ahead and move my database back over to SQL 1. Now when I say move, I'm just moving really the write capability. Both databases do exist on each server. It's just the only one server, which is the primary, is able to accept write requests. Okay. Our next step is to implement a read-only replica. When we set up our availability group, we allowed both databases to be readable secondaries, and they're both set up with what we call a read intent only. And what that means is you have three options. You have no, read intent only, and yes. If the database is set to no, it will, when it's a secondary replica, will not allow any connections into the database. It's basically unavailable for anything. When it is set to yes, it will allow all connections into the secondary database, regardless if they are for read write or read only, but it will error out if a write attempt occurs. Read intent only will only allow connections to be made that are actually marked as a read-only connection. So we're going to go ahead and leave that setting set in our availability group. The next thing we have to do is set up availability routing. So to do this, we're going to alter our availability group and specify a read-only routing address. And this address is going to be identical to the connection address for that actual server. So when I'm on SQL 1, I'm going to show my connection to SQL 1. On SQL 2, the connection to SQL 2. I'm then going to go into the availability group, and I'm going to build the actual route. So if SQL 1 is the primary, it's going to read-only route to SQL 2. If SQL 2 is the primary, it's going to read-only route to SQL 1. If you had more than 2 servers in your replication group, you could actually add additional servers into this routing. Now let's see the application in action. If I go look at client 1, I'm going to leave the connection string the same here. So by not specifying an intent, the application assumes that my intent is to read-write. When I run client 1, all of its access is going to be against SQL 1. And we can see that by going into Profiler. I've got a profile set up on SQL 1. I'll go ahead and run that. I'll requery my data, and you'll see all the execution took place on SQL 1. That is because, again, this application has a read-write intent. If I go into client 2, which is the same application, the only difference now is in my connection string, I have specified an application intent of read-only. When I go ahead and run application 2, you'll see the access of data, but you notice that the select statement is running on SQL 2. Let's show that one more time. If I go to 1, that select statement gets implemented on SQL 1. If I go to 2, that select statement gets implemented on SQL 2. So my applications, based on their intent, are routing to either the primary or replica server. This is a really nice way where you can offload read-only applications such as reports, internet applications that don't allow data entry to that secondary server. Because always on is kept in sync all the time, the route and the reporting that you're seeing is real. It's real data, real-time data. It's just offloading that setting. SQL does do a good job of implementing temporary statistics on that always read-only replica so that you will get the best performance out of that. I hope this demonstration was useful to you, and look for future demonstrations from John Ecken and Tandem Solution.